session, Computational Intelligence. So we will begin by the first conference by Éric Poirier, who is Associate Professor at Université du Québec à Trois-Rivières, where he teaches methodology and specialized translation in the undergraduate translation programs offered online. His research areas are applied linguistics and translation studies. His research interests and publications topics are bilingual lexicography, corpus translation studies, translation didactic, natural language processing technology applied to translation processing and quality assessment, as well as source on target language, phraseology, description for translation teaching. So it's for you for 20 minutes.
Thank you very much, Christophe. Thank you for your committee to invite me to present my work. So I'm a translator, I'm a linguist, I'm teaching translation online, and my main research interest is in the cognitive process or modelizing translation processes. Traditionally in translation, what we do, we give students a text to translate and we analyze the results, but we don't know what happened between the first text and the results. So I'm trying to develop some modeling or techniques to better know what the processes are in translation. And in this field, I created an alignment heuristic that I propose to my students, and I'll present it today. So that's the subject of today. And the context is an algorithm I did at the MEDES in 2014, like 2 years ago. I've implemented with students the algorithm. It's working good for French, English. We're developing it for Spanish too. And now what I'm looking for is to compare data with the results of the algorithm. So what I'm presenting today is the heuristic that I would teach to human people to do and to use those results to compare with the results of the algorithm. So this is the background. Okay, I was already in advance, but the context is parallel text. In translation, they are numerous, they are very ubiquitous, and we find the parallel text in translation memory database and bilingual concordensers online. So the input of the heuristic and the input of the algorithm are parallel text, automatically segmented parallel text. So that's the context of my work. The outline of my presentation today, I will give some background, the purpose of the manual alignment heuristic I'm proposing to my students. We'll see the basic rules and principle. I give some examples of simple alignments we do, and I'll present some special units required to use in alignment. And I'll briefly discuss about isomorphisms and anisomorphisms, because those are categories, like we spoke about labels a little bit in the earlier our keynote speakers. And anisomorphism and isomorphisms are labels of data. So it's really it's not complicated, but it's interesting because it shows how it gives different ideas of what the translation are. And I'll finish with conclusion and further studies. So like I said, as a background, I did an algorithm, and I presented the results at the MEDES in 2014. It's a Python program with 3 modules. It's fully functional in English, French, and now we're working on Spanish. What it does, okay, simply put, it's really a rough evaluation of translation precision by counting the number of content words in source text, which is A, and in target text B, and calculate the translation precision by dividing B by 8. So to determine if there is additional material, if it's more than 1, then there's probabilities that the translation will have more content than the original, the source text. Or if there's missing something, some content, then the precision will be lower than 1. Or if it's similar, this is equal to 1. This is really a rough evaluation of translation, but it's interesting because it gives some basic results about the quality of the translation. I'm not inventing anything, okay? This is already used in automatic translation, except that in the automatic translation, what they do is they evaluate the automatic results with human professional translation, and they do the exact same evaluation. The difference I'm doing is I'm taking into account only content words. I'm taking out all the function words in the segment. So that's the basic difference. And hopefully the algorithm is normally to be language independent, but difficulties are to be expected with compounding languages such as German, because there's no separation of words with blank spaces in German. You may have a lot of compounding words, but it could be resolved, but I'm not going to address it here. So this is the background of the heuristic. So the purpose of the manual heuristic is to propose a manual word alignment method within the input of segmented text, automatically align parallel text. Like I said, there are two goals of the heuristic. It's first, it's a human basic evaluation of existing translations. It helps students to learn translation process with translation results, so they can compare the quality or the basic rough quality of the translation. And like I said, it will help to make comparison with the algorithm result that I already have. So, basic rules and principles of the heuristics. Remember, it's a manual method. It's not automatic, it's manual. So that means their meaning are processed. So there are 2 steps and 2 rules. First is to identify content words in both source and target segments. I said it's not trivial, because sometimes these categories, grammatical categories, are not easily associated to some occurrences or to some tokens, to some word tokens. And only source and target content words are aligned. And the rules, so this is the step 1. The second step is to associate content words to align content words to at least one target content word or empty token. Empty token, those are the same that are used in the automatic translation models, so it's not new. And the principle of association now, which is really important. You have to find a content word in target segment meaningly linked with content word in source segment. So that means that in order to be able to make the alignment, you have to understand the languages. If not, it's not possible. So that's why I'm saying it's a manual heuristic. And the principle of association, they are both. They are meaning-based or what I say function-based. I'll give you examples a little bit later. There are particular cases that need to be mentioned that we don't process auxiliaries, which are the verbs to have to be all the most common verbs used in languages. And there are some decisions we have to make about the negation. In French, there is ne pas. So we decided to treat ne, for instance, as a function word and pas as a content word, which is arbitrary. We could have decided the other way. And there are also idioms that are a special case of alignment where there are one-to-many or many-to-many relationships with idioms. So those are special, the rules, the basic rule. It's really basic. It's really, that's what makes it interesting, is that it's really simple. So I'll give you an example of simple alignments. It's the source segment in French is à vaincre sans péril, on triomphe sans gloire. Here, and in English you find to win without risk is a triumph without glory. So I numbered, for the purpose of the presentation this morning, I numbered the content words. Like the content word, first content word is vaincre, péril, triomphe, and gloire. Same thing with English. So the informative content alignment would give us 4 pairs of aligned content words, which are here. So that makes translation precision of 1, which is 4 divided by 4. And in this case, it's really a simple one because you have the same amount. The informative content alignment would give us okay, so that the previous example was about meaning-based alignments. There are also function-based alignments you may do. This example is an example of a function-based relationship or linking, which is in this occurrence where there is a host of, which is linked dans le cadre de. And the reason it's function-based is because there's no meaning that are related to each other, but both expressions having the same function within the sentence or within the segment. So that's why I call it function-based, because there's no meaning relationship, but their function in the sentence is similar or identical. So you can find here that there are examples of auxiliaries I was talking about a little bit earlier. So those are considered as function words. They're not taken into account in the content words account. So you may calculate the translation precision of this sentence with the other one, and it gives you a number, so it's lower than 1. And if you take into account functional words as a half point, let's say, it would make your precision a little bit higher. But those are just ideas, you know, it's not, like I said, it's a rough evaluation of translation, but I think it's interesting to do this way, especially for, you know, you have to remember we're addressing translation students. So we're not necessarily addressing this kind of heuristic to general public. It's really specialized to translation students. So it makes them aware of the different processing they need to do to translate. Like I said, there are 2 special units in alignment. There are the empty tokens and the multi-word expressions that are processed differently. Empty tokens is when you have no meaning, like the method is to go through first with meaning content-based alignment, and then you go to functional-based alignment, and then if there's nothing in your segment that correspond or is linked with your content words in the other language segment, then you may use the empty token or the null token. We may say the null token. So this is the use of null tokens is when there is no content word in the opposite segment, or it's aligned with a function word in the opposite segment. The multi-word expressions is the when there are idioms. So, like I said earlier, it's those correspond to the situation when there are one content word in source aligned with multiple content words in target, or there are multiple content words in source aligned with one content word in target. We'll see. I'll give you some examples. how we do with the time? It's
I will take you.
okay. So there's an example with null token or empty token. We have the different content words in the sentence. The null token, the one form of, has been translated by nothing in French. So this is a case, an instance of the use of the null token in the alignment of content words. As you can see, there is also a lot of multi-word alignments. In English, when we say we pledge our word, there are two content words. And obviously in French, there is just one. So this is a case of idiomatic or multi-word expressions here that can be found from the alignment where there is more than one content words associated to just one content word. And I gave, for the sake of probabilities, I gave some precision calculations. If we take into account the multi-word expression and not. What is interesting is by taking into account the idioms, you get closer to a precision of 1. Of course, because it's part of the translation process. Is you like to translate idioms regularly. So that's an example. Okay, we're coming to the isomorphism and anisomorphism. What are they? We found that translation precision may have 3 different values, like I said earlier. When the precision is equal to 1, we could say it's an isomorphic translation. That means that there is the same information content in both segments. So probably we have high expectation of having the same the good translation when we have this occurrence. Of course, it's not always true, but it's just a probability or more regular situation. And that's what is interesting also is that when we translate, we tend to work as if the precision of 1 was the ideal. Like it's a norm, it's a standard almost. When we translate, we're aiming at this precision. And what makes it interesting, those numbers too, is that when the precision is different than 1, then what happens? Well, how can we explain this? So there are different situations which are, so those cases are anisomorphic translation, and those are the very interesting data that needs to be studied. When we speak about anisomorphism and isomorphism, we have to not confuse a very different concept, which, I was talking about linguistic science and translation studies. It's really different in linguistics. Anisomorphism and isomorphism are defined very differently. For instance, in linguistic or in dictionary making, somebody is worried about something. We have a translation which is quelqu'un préoccupe quelqu'un, quelque chose préoccupe quelqu'un. So it's a very anisomorphic from the way of expressing meaning. But in translation, it's really isomorphic somehow because it's a predicate. It's the same. We have the same argument. Okay, it's just that they are expressed differently. So it's really isomorphic. It's just the form is expressed differently. So from a meaning point of view, it's really similar. That's what I want to say. But so this is some results of the definition of anisomorphism and isomorphism and the difference in linguistics and in translation study. I don't think I have the time to go into much details, but it's really a promising field of research because with this kind of data, we can see the translation noise, the silences, the false noise, the false silences that are present in translation, and that explains to students their error, their translation errors. Like if they make an omission, you can calculate that there's a silence in their rendering of the source text. So that's really an interesting way to explain to students, hey, you have made this mistake in your translation. Can you see it? You know? So that's why those concepts are interesting. I don't have to go into the time to go into details about the causes of translation anisomorphism. Like I said, more data is needed for the analysis of more segments. So I'm working on having lots of segments to have idea of why, what's the difference. For example, in the data I have, in English we often say in the world, so that there are two kind of hypotheses. There are syntagmatic expansions, like in the world. In French we would say dans le monde entier, and we wouldn't say dans le monde. It's not enough to say it in French. And same thing for a lexical. So there are two movements: syntagmatic expansions, lexical condensations. Those are kind of two movements in the translation process. And for example, as a lexical condensation, when we say in English in America, we have a tendency in French to say dans le continent américain, or we may as well say aux États-Unis or in the United States, but this is a kind of lexical condensation. What is interesting also is to analyze the anisomorphisms that are mandatory and those that are optional. So you can teach to the students, okay, this is mandatory, you have to translate it this way. And if it's optional, well, it's up to you, it's your decision, but both ways are correct. So those are just small example of anisomorphism. Obviously, there's some need to study it further. I will just go to my, well, like I said, the idiom chunking is interesting because the translation tendency is to, okay, so I'll go to my conclusion. So the advantage of meaning-based manual alignment heuristic is that it's an autonomous measure of human or automatic translation precision. We expect to be able to measure recall, but it's not done yet, so I expect to do it sometime in the future. What's the advantage of the heuristic is that there's no need for translation reference. You may compare translation with source and target. It's autonomous comparison. While as in automatic translation, they always have the machine and the human to be compared. So this heuristic doesn't require another translation, a third translation. It's potentially language independent to be further tested. It's also for studying, for students, it's really important because it's manual, it's slow, it's simple, so it makes it learning very easy. And I hope it will allow for benchmarking the automatic content word precision algorithm I made previously. So that's basically the end of my presentation this morning.
Thank you very much. Is there any question? I have.
You said, Eric, that
yes.
your algorithm is language independent,
Yeah.
except for German, I think,
Yeah.
something like that. Is it
So it's not language
is it for languages writing from right or not?
I don't think it's relevant the direction of writing, because in fact what I didn't say is the meaning linking are not syntactical, are just logical links. So you don't have to take into account the syntax. You do have to take account the syntax for meaning understanding, but the result of the linking is not syntactically dependent. And perhaps an interesting way to resolve the problem with German would be to list all the common words in German in order to make the links correctly in the source and target language. Instead of the algorithm I use now is just for function words. It takes out function words of the segment and it then processes the alignment with the what's left, the residual words that are left when you take out the functional words. But an interesting way to resolve the problem with German would be to list those words, all the German words, and identify them in a compound. That would be another way to resolve it.
Just a bit correction. What kind of relationship you use to make the alignment?
What kind of relationship?
The relationship you use for the alignment. Could you characterize those relationships?
It's meaning based or functional based.
Okay.
Functional based is more complicated because it depends on the relationship of the item in the sentence. And if the item shares a lot of relationship with other items in the sentence, then you have a match because it has the same function in the sentence.
Okay.
That's a rough idea.
Okay. Thank you.
Other question? So I have a question.
Yes.
It's different from. It's near the question of Hammou Fadili.
Yes.
So, do you think it's universal? Your heuristic function is universal. That is to say, universal to any kind of
Language?
With different grammar, because here you speak about alignment between French and English, and also Spanish.
Spanish too.
But if do you think we can try to use your heuristic with Arabic or more different such as Japanese, Korean, or Chinese?
Okay, I think the problem with this kind of approach is that there's the frontiers of words have to be blank spaces or symbol, which is why there's a problem with German, because when you have compound or free compoundings, there's no delimitation of words, so you cannot isolate. Although you may do it if you understand German, you may easily make the links of the element of the compound with other elements in the other language. It's just that you cannot do it automatically. But since my heuristic is manual and human-based, somebody who's understanding German can easily make the relationship or the links with the other language. It's not impossible. It's just that it's not automatically feasible unless you have a list of German elements that may be combined in a compound, and then you identify those elements, and then you count them as content words. So, yes, it's possible, but it would need some adaptation. And for some language, I don't know, it's difficult to tell, but I guess I checked with Chinese person, and it seems to be feasible because they do have all content words in Chinese too. In Arabic, you do have content words too. What's interesting is that when you're bilingual, you may use this method to your language you master, and it makes it more easier for you to evaluate or to measure the translation quality. It's a rough translation quality, but it is. I mean, if you had material in the translation, you're making an addition, so you have to justify why you had material.
Thank you very much.
You're welcome. Thank you very much.
So we will continue with the next the next one. The presentation it will be done by Frédéric Simard. I present you while you are manipulating. Okay. Frédéric Simard is a doctorate student in computer science at Université Pierre et Marie Curie in Paris, France. He studies that the study of algorithms for detecting communities in streets, also known as temporal network. He works in network science, and his research interests are network algorithms and graph dynamics. He has already presented at three international conferences in artificial intelligence and constraints programming. Please.
Thank you. So this is a joint work with Josée St-Pierre and Ismaïl Biskri, both at the Université du Québec à Trois-Rivières. So some of you may know searching for information in small text and can be quite hard, mostly when the text has expensive vocabulary, so the vocabulary is quite large, because this is basically we're basically tackling the statistical problem of trying to find patterns in small data sets with high variance in the variables. So when we do that, we sort of need to try to normalize the words, to try to aggregate the words in order to try to find relevant patterns. So in our context, we interviewed 17 different entrepreneurs using what is called the Think Aloud protocol. So basically all the entrepreneurs were asked to say out loud how they reflect, what they think when they were faced with an opportunity of investment in an unstructured environment. So whether they would invest, how they would invest, with whom, etc. And all the things that they said, all the things that they thought, were recorded and transcribed into text. And our goal was to try to find patterns in those texts, to try to find cues into how the entrepreneurs reflect when faced with opportunities of investment. Now the problem is that we expected all the entrepreneurs to use specialized terms such as investment, risk, opportunity. However, most of them did not. One reason for that is that most entrepreneurs did not share the same backgrounds between themselves, nor with the experts. So the entrepreneurs themselves, between themselves, use different words to express the same meaning. And we thought that they would use some words, some specialized words to express this meaning, but they did not. And so trying to find patterns between all these different words that share the same meaning was hard. So basically our research question could be summarized as would using a dictionary of synonyms to try to aggregate the words that are expected to share the same meaning help us in using a text mining method known as Maximal Association Rules Discovery in order to find meaningful patterns in the text. Now, maximal association rules are basically a refinement of a data mining tool that is called association rules that started in the 1990s. An association rule expresses a statistical relationships between two variables or two sets of variables that is found in the data. So, for example, an association rule x goes to y expresses that whenever the variable or the subset of variable x appears in the data, then with some statistical significance, the variable y will also be found in the data. And these rules are evaluated or quantified with some measures called such as the support and the confidence, where the support is basically the statistical significance of the association. So it estimates the joint probability of observing both variables, whereas the confidence estimates the conditional probability of observing the variable y given x has been discovered. So for example, if the confidence is too low, we could estimate that the variable x is in a greater relation with another variable than y. So we use the Hammou software in order to try to discover association rules, maximal association rules, because maximal association rules, it has been shown that they tend to discover more relevant patterns than normal rules. And so we're basically trying to find rules between words. And so we were looking for association rules such as opportunity goes to risk, where this association here would express the fact that whenever the entrepreneurs thought about the word opportunity, they also thought about the concept of risk, so they associate risk with opportunity. However, trying to find statistically significant relationships such as these were hard, because instead of the word risk or opportunity, the entrepreneurs used many different words. So our method was to try to use what we call synonym sets, so sets of synonyms to try to aggregate the words that are considered synonyms. So basically we just swept through the text and replaced each word with its closest set of synonyms. And whenever two sets of synonyms seem to contain the same word, we try to compute whether we could merge these syn sets in order to end up with the least number of aggregates. And then we try to find associations between syn sets, so between sets of synonyms. So try to find association between meanings. So for those who speak French, we have an example of syn set here. So basically we have rival, adversarial, competitor, and challenger, so they are considered a synonym in French. Now this is still an exploratory research, so the results would not be too much taken out of context, but basically we gathered the data, so we transcribed the text, transcribed into text the recordings of the experimentations. We used a lematizer on the text to try to bring back the words into the canonical form. We use apply the syn sets. There's an optional classification method can be used, but I'm not going into the details of that because it's optional. And then we extracted association rules between those syn sets. And now, because association rules can naturally be expressed as a graph, we visualize the results, the set of association rules, as a network, and this network is the object that we analyze further. Now, as I said, association rules as x goes to y can naturally be written as a directed edge in a network, where x is a node and y is a node. So, for example, here we have the syn set of group. And here we have marché or market, and there's an association between group and marché. And so it helps us to visualize the structure of the set of association to try to better understand how the entrepreneurs thought. And since we have now a network, we can use tools from network science to try to further analyze this object. So yeah, we try to use network science to better analyze, to better extract relevant information from the networks. We tried many different tools, many different methods. The method that worked the best is the one called the centrality measures. A centrality measure basically measures how much a node, the tendency of a node to be important in a network, how it is central in a network. For example, we say that all roads lead to Rome. Well, Rome must be central to the network of roads. Another example here, we have all the nodes are colored from red to blue, with the blue being the most central and the red being the least central. So if I were to start a rumor on this blue node here, it would spread more on the graph, on the network, than if it were to start on a red node. So finding the most central node can be interesting because it sort of tells which nodes are in our association networks, which concepts are the more important. So here we have an example of a network that was produced when we used synsets, so before using the association. And on the right, we extracted the association rules without using synsets. So in order to compare, we can easily see that the method using synset leads to a lot more association rules being discovered, so more relevant patterns are extracted. So using synsets leads to is actually a simple word clustering method that can be used on small text without training data, which is actually one of the biggest problems that we had. We could not use too many complex clustering methods because our texts were too small, so we could not separate between training data, test data. We could not use unsupervised methods again. So the using synsets was really the most applicable method here, and it did provide interesting results. However, there were still some negative points. Actually, the dictionary of synsets was written in France at the University of Caen, whereas our entrepreneurs were from Quebec. So there's some discrepancy between French from Quebec and French from France. It's basically like the same discrepancy between American English and British English. So there's some words that were considered synonyms in France were not considered synonyms in Quebec, such as in France the word entreprise is considered synonym to affaire, whereas in Quebec entrepreneurs do not use entreprise is synonym to boîte in France, whereas in Quebec entrepreneurs do not use the word boîte. Now, so although there is this major drawback, there's also the fact that the dictionary of synonym was not a specialized dictionary. So some words, for example, compagnie was considered synonym to groupe, whereas in Quebec, compagnie, it was expected to be a synonym to entreprise or affaire, so business. So however, with all these drawbacks, the number of interesting results, interesting associations that we found as measured by the relative recall was really higher than when we did not use synsets. Now, the use of network science to analyze the association network is actually an interesting idea, although some classical tools and methods from network science were not did not produce interpretable results in our case. So, for example, block decompositions, network flows, cycle decompositions, and all of these classical methods did not produce relevant results in our case. So the most so we still need to try to create new methods to try to generate relevant information. In this study we did not create new methods. We tried to just experiment with like out of the box tools that could be extracted, could be used from the available libraries. But in a further study, we would need to create more richer tools in order to analyze the association networks. So the most important tools that we used were the centrality measure, such as the PageRank algorithm from Google. And so, for example, here we see that this node here is the one that maximizes PageRank score, and it can visually be seen as a node that is central to the network because it's really, there are more association towards this node than towards other nodes. Another interesting thing with synsets and centrality measures is that some words that were found to be like the most central according to some measures when we did not use synsets were the same when we did use synsets. So, for example, here on PageRank, the most central node according to the PageRank was entreprise when we did not use synsets, and entreprise is contained in the synset of A5. So when we used synsets, it was still the same most central node. So some measures are sort of stable when we use synsets. So in conclusion, using synsets provides us with a simple word clustering tool that can be easily applied on small texts. Association rules can be naturally written as a network that can be further analyzed using network science. Now, although the results are interesting, they're not generalizable at this point because we still need to further refine the use of the dictionary of synonyms, and we still need to create more creative methods from network science in order to really produce more relevant, deduce more relevant patterns in the data, in order to really understand, get better cues, better hints into how the entrepreneurs took their decisions. Thank you.
Is there any question?
I'm wondering, I just think about the mutual information, your relationship. Is it related to the relationships you were exploring at the beginning? You talked about some kind of relationship association. Do you know if it's related to mutual information association? Because this is an important measure, but I think it needs to be high, have a lot of data to be.
Like in information science, right? Information.
Yeah, mutual information.
Yeah. I
association. I'm just wondering.
Well, I'm not sure, but I think you can use like mutual information to try to quantify the quality of an association rule. Because an association rule itself is not like, it's an object, but it's not a mutual information. It gives a number.
Okay.
So association rule really is it's an object. It's a relationship between.
Is it possible to use your tool to enrich French WordNet because you are
French WordNet? To what?
WordNet. Do you know WordNet?
Yeah, we tried to. Yeah,
because
well.
your work is similar than what you can WordNet.
Well.
WordNet.
Yeah, well, we try to use WordNet. There is a French WordNet project that we try to use. But actually, the association, the network that is produced in a WordNet is not a network that is. It's not like an association network because
WordNet is a construct on sunsets.
But it's like an ontology, right?
Yes, an ontology.
Okay, so that would, yeah, I think you could try to use network science to try to analyze this, but I think there's a difference between an ontology and the association network because here the words are considered linked because they appear together in a text, whereas the ontology with WordNet is constructed by experts, I think. So stuff like that. I'm not sure if this answers your question.
Is there any other question? Perhaps the baby has a question.
No, but so therefore the problem in having small text is that not being able to compile many statistics in relation to calculate the relationships.
Yeah.
I think that's the basic.
The basic problem is like I presented the support, which is sort of this whole level of. Basically, the support would often be too low. So if you have, if you observe opportunity goes to risk like once in all the text, well, you're not sure if it's really interesting or not, so you can't.
Statistically.
Yeah. So and the problem is you cannot discard it because it might be interesting,
Yeah.
but you're not sure.
Or maybe. Go ahead. No, but maybe if you could compare it to large corpora, and maybe that would be a possible interesting avenue. You could make reference to large corpora and see if the statistics are different or like deviation from a large corpora. But
Yeah. I think the problem is try to come up with the corpora because
well, business. I mean, there's a lot of business stakes. It's just that it's true you have to create it. I mean, there's no.
yeah, but if you look, for example, in business journals, the vocabulary is more specialized than what we ended up with. So you really have to obtain the vocabulary that's sort of comparable to what we have.
Okay, thank you very much.
You have
Excuse me.
No,
No?
time?
Yeah.
We have time? Well, it's just a quick visit because I'm not from this area and maybe my question is kind of silly, but just to see that the association rules are predefined or are defined during the process or
Actually, like the association rules are extracted from the text.
From the text.
So
But
like
it depends on the context, right? Because in this case, in the context of enterprises and those kind of terms, right?
actually it can be used. It does not depend on the context. It's just like statistically, if two words appear like really often together in the same sentences or paragraphs, we will the software will say that these words are associated. So that is not dependent on the context. Or anything.
Okay. And then from this graph, you extract more information, or you can analyze the text.
Yeah, well, we thought we sort of extract more information from the graph, but from this point, we did not extract enough information to really say that. To really conclude it's an incredible method.
Okay.
Okay, there is another
Just
question.
a small question. I already work with the association. For the confident, there is like a percentage. It's mean that not to just find it, for example, in one sentence that two words they are in just one sentence. You can say that they are associated. How do you use the association rule to say that they are associated? It means you calculate in all the text if the two words that are often together. It means how often. It means how many.
Well, actually, I'm not sure if I understand your question, but it depends on the methodology. But I think you could try to define. I'm not sure.
I will give you an example.
Yeah.
For example, there's an example that we can say that the person who buy caviar is so for this 10% who buy caviar, 80% buy champagne or wine with this. So this is the associated rule. It means that with this word, we found that 80% of in the text of the sentence contain this word.
Yeah.
So how the percentage that you use it to say that they are associated?
This percentage is sort of a global percentage in all the text and in all the transcripts that we use. So in the percentage, like two words are considered associated if they often appear together in segments. And I think the segments that we use, like how we segmented the text, I think it's by phrases or paragraphs. So if we segment by phrases, then two words are associated if they often appear together in phrases, and you just to evaluate the confidence, you just there's a simple formula that counts the number of times both words appear together in the sentence divided by the number of. So I'm not sure if.
French is easy for me. Thank you.
Thank you very much. So the next presentation will be in two parts. The first part will be presented by Hammou Fadili, who is senior researcher at Conservatoire des Arts et Métiers in France, Paris. He is also associated member of LIPC, University Pierre et Marie Curie in France, Paris, and CNRS. Inside the EC3 project that we will present now, inside the l'ABEX Obville, Observatoire de la vie linguistique, de l'Observatoire de vie littéraire for digital humanities. So,
thank you, Christophe. Our presentation is entitled toward automatic analysis and standardization of unstructured data in the context of big data and limited data. That concerns the project on which you are working in l'ABEX Obville for digital humanities. So, as you know, the World Wide Web is a dynamic and ever-changing world, generating a large corpus of heterogeneous data, as we say, big data. 80% are in unstructured format. They are also not annotated. So the problem is how we can not do without unstructured. We cannot do without. So because they are also precious, this implies the need to develop sophisticated process allowing to the automatic analysis. This implies also the interest of new researchers. So I will begin to define some keywords used in this presentation. After that, I will present the objective of this work, the motivation. We will present some related works, and a comparative study of some existing and unknown solutions. The second part will be presented by Christophe, our contributions, the foundation of the tool C3 and the application. After the conclusion. Okay, linked open data load is a set of methods, norms, standards of publishing normalized, structured or annotated data in order to be interlinked and searchable through semantic queries. Linked open data is an implementation of web semantic web. Big data is characterized by large volumes of varied data generated and shared quickly. It's characterized by the 3 V's: volume of data, the speed with which we generate data, we generate and create data, and variety. Smart data are the result of analysis of text analysis. They are the interpreted and unambiguous, usual and useful data. So the objective of our work aims to develop an approach that consists in a cyclic process. Donc we exploit load to analyze the unstructured data. We extract the relevant information, we normalize them, and then we connect them again to the load to complete our cyclic process. Okay, the motivation. I will present the motivation into sections. The first one I will present some related works in the context of X data, donc low, speed and smart data. In the second part, I will present some unresolved issues until now by means of a comparative study that we have done. Okay, in the context of linked data, we have three categories of approaches and tools. Those which use load to analyze unstructured data, those which connect unstructured data to the load, and the third category consists those combined two approaches. I mentioned two examples in this category: the modifier, which generates and link data from unstructured text, and the semantator, which exploits semantic data annotation for converting biomedical text to linked data. Here's a graph from the modifier. It combines several technologies to perform semantic text analysis and their integration in the load. Now we begin here, and you can see here the load linked data to
a low cost is.
It's based on name entity recognition. Here, word sense disambiguation based on the controlled vocabulary coming from load. And then we extract entities and relationships from text, convert them to RDF, which is the basic language for represented text in the load, and then they link them to the Wikipedia or WordNet, which are two implementations of load. For more details on this tool, it is described in detail in our article. In the context of big data, the aim is to convert unstructured data to destructured and semantically annotated format. In this category, we have two. In this context, we have two categories: those which exploit text as raw materials, as text. They use natural language processing techniques to perform semantic analysis. In this subcategory, we have two examples: onto text, which converts big data to smart data. The tool ASCII that manages semantic big data for intelligence, and semantic engine using brain-like approach SEBLA, which process semantics in the context of big data. The two categories is those who expert on everywhere. They use allow structured data, key and value, like NoSQL, to perform data analysis. Example: the big data implementation by Google, the Dynamo by Amazon, or Cassandra by Facebook. We make a comparative study in which we study some known tools like Alchemy from IBM, Annie from Gate, onto text, and here semantator and modifier. And we test this functionalities like tokenizer, the gazetteer, splitter, part of speech trigger, recognition of name entity recognitions, etc. And we can see that almost of the tools implement the basic functionality of NLP, but not the contextual, the real contextual and semantic interpretations of text. We do test with ambiguous text, which performed via these tools, and the result it is not good. Okay, the conclusion for this first part is that many solutions begin to use one part of the web, the load, because we don't have enough structured or annotated data to normalize the other parts, the big data. Many problems remain unresolved, especially in terms of semantic text analysis. In this context that we are currently constructing a new approach based on two important notions: the concept of context, to determine the real means of text disambiguation, and the concept of semantic relations. Okay. Now, it's Christophe Jouis that continue the presentation for the tool that we have implemented. My turn to introduce Mr. Christophe Jouis. He is a senior lecturer, maître de conférence at Université Paris-Sorbonne, Louvain, attached to the presidency
and ellipsis, CNRS, Université Pierre et Marie Curie, équipe ACASA. Current position since September 1999, senior literature, double discipline, compétences, sciences and information, science and communication, Université Paris 3, sur Bonne Nouvelle, attached to the presidence of the university. Okay. Christophe, have 10 minutes.
So, our contribution is a software called EC3. The goal of EC3 is to extract pertinent information from heterogeneous text from a point of view, such as semantic relation between main entities and, for instance, also who speak about what, from which, citation, etc. The method is original because we don't use syntactic analysis, no universal or domain-dependent dictionary or ontologies, and contrary to the other contribution here, we focus on anti-words that are in fact the real knowledge of a language. The foundation of EC3 is applicative and cognitive grammar, created by Professor Jean-Pierre Desclés, Paris-Sorbonne University. It introduced 3 levels of representation: morphosyntactic structure, applicative and predicative structure. That is to say, we have a predicate, a set of predicates applied to arguments, and a linguistic operator, such as aspect operator, temporal operator, or registry, such as it is a story, or it is something said by somebody else, etc., etc. And the last level is cognitive level. It's the level of where the meanings of linguistic units may be analyzed under the form of layouts, semantic cognitive representation, in order to constitute the knowledge representations associated to a given text. Our hypothesis is that this level is universal to any language, not the two first levels. Main idea of this software is that connectors between terms is a set of language indicators to isolate semantic relationships between terms concepts. These indicators reflect linguistic knowledge independent of a particular field of knowledge. This is our EC3 architecture. We have a contextual exploration engine that use data that are indicator, that is the connector between terms. Very important, you have to define before, for a point of view, a set of organized semantic values that are well defined by property, mathematical property, algebraic property, and also a set of contextual exploration rules. So this is the data in the engine. In the engine you have a raw corpora that is automatically segmented. The engine run, and you obtain automatic annotation and annotated corpora. So, as I mentioned before, SC3 is a knowledge-based system. It consists of contextual exploration rules in the form of if condition then conclusion. The condition expresses the presence or absence of certain part of certain indicator or absence of linguistic units, and the conclusion permits to progressive construct the representation of knowledge representation of text. In our case, it is semantic relationships between words. Researching sequence of linguistic units. I insist here about what I call sequence of linguistic units, because in our position we don't know exactly, and perhaps we can discuss after, we don't know what is the definition of a sentence in any language. What is exactly a sentence? We can speak about sequence of linguistic units. SC2 software has been implemented by the version. This is the third version. In French, we have 200 rules and 3,000 markers. For example, you have a rule who express the presence of a certain number of markers, and we conclude that in this sequence of linguistic units, we have a relationship of part of more clearly. In French, it is a part of a corpus of from Renault, a French car manual, where we focus on not on the term. The system don't know what is airbag or inflatable bag or gas generator, etc. They focus on specific connector between terms. Here you have the affected markers. So there is a lot of this marker. And at the end, the user see a graph, a special graph that is built with the use of a grapher called Graphlet, which has the advantage of having many layouts. And I will explain why some of the nodes are in yellow and the other not. So when the user searches for information from the graph, he navigates in the graph or subgraph. He selects a term relationships term in RDF format, which allows us to connect our output to link open data. And it returns to text portion to link graph, that is to say text portion associated, part of text that allow the construction of select subgraph. Just a more precise interface to the user. So here you have a graph, and you can select one or more triad, you can distinguish two kinds of node. The yellow node are, in fact, the principal node of a part of text, because they are considered of the principal node because they have a lot of link between the other node in the graph. And then you select, so the user select part of the graph and a hyperlink return to the text where is you can see the text in French here. So in English, it is, you recognize that it's about airbag, and it's a part of, it describes the composition of one airbag. Conclusion. In fact, our project consists in implementing a cyclic process. Consolidating our previous work and tools to be compatible with the standard of semantic web and its implementation in LOD. Exploiting the structured and annotated part of the web, LOD, as training data. Computing semantic text analysis and the unstructured part of the web. Extracting relevant data, smart or interpreted data. Standardize the obtained data according to semantic web and LOD, standard for norm, etc. And connecting the new standardized data in the right place of the LOD. A C3 problem and generalize the all previous contextual exploration application. It has been tested on many corpuses in French, English, Spanish, Arabic, Korean, and Japanese. And is actually tested on a very large and heterogeneous corpuses thanks to Oppville Labex, Observatoire de la vie littéraire. It's a very large and heterogeneous corpus of a lot of authors provided by the University Pierre and Marie Curie in collaboration with Paris Sorbonne University, and also all the numérised corpuses of the Bibliothèque Nationale de France. Thank you very much. If you have any questions? Yeah, the question.
What kind of, I have a question about an example. What kind of example could you provide us with a rule? You said you have a if condition, then conclusion.
Yeah.
Could you give us an example of any rule that would apply to this canon?
I think I have one. If you I was too quick. This is one example of. So I will explain in clearly. Okay. So it's the name of a rule. If we observe 4 linguistic units
This is for the
that are in a database of list of marker,
Okay.
and P a sequence of linguistic units. If X1 is an occurrence of the verb had to be, or what of the symbol full stop, etc., etc., and X2 is in the list alien 3, alien 3, alien 4, alien 5. They are here.
Okay. Synonyms. So those are synonyms.
Okay. And followed by another marker in the list avec de pas, followed by the linguistic unit de, or equivalent in French, di, des, du, and the four marker follow in P, just a position not exactly not followed exactly immediately.
Okay.
For instance, in the next slide, in French, chaque système airbag est composé de, to be composed of. You can have the sentence, each airbag system is, virgule, as we said before, composed of, etc.
So in fact, those are patterns. Those are patterns looking.
It's not exactly pattern.
No.
Because you can have one marker, a lot of linguistic units, and another marker, etc., etc.
Okay, but if you don't have questions,
I have a question.
You have a question for you?
You have no. So at the beginning, I said that I don't know what a sentence. In fact, it's not a dangerous question, because as you know, in traditional NLP program, you have very often or syntactic analysis combined with a dictionary, or the approach with statistic and n-gram, for instance. But in all these two kind of approach, you have to define a beginning and the end of a part of the text in order to analyze it. More precisely, if you use a robust syntactic analysis, you must have define what is a sentence, and you must have a text that is clearly grammatically correct. In our approach, some of governmental and non-governmental organizations are interested by our approach because we can analyze part of text such as SNS or something not syntactically correct in order to extract information. Okay? So,
What can I add is that the tool presented by Christophe work well on big corpuses, but on desktop versions. So we apply this tool on many text, many raw text in the LabX. But the problem now is that on which we are working now is to encapsulate this work in the context of linked open data, in web semantic form. We are converting all inputs and outputs to be integrated in the web, in the structured web. Not, but in some what we are doing this project.
Okay.
So you're talking about unstructured data, textual data, more than structured data. Because in structured data, there are alignment tools that are working pretty well.
Fadili is more used.
Yeah.
Oh, it's okay. I'm just curious because the problem with the alignment is more important in unstructured texts than
Yes.
in structured text. In structured text, there are alignment tools that are very efficient.
Yes. What we are doing now, Christophe shows in our slide the output as RDF. What we are doing is to search in Wikipedia on WordNet RDF, not the load version of those implementations, to extract the UID, the universal identifier, and to link it to the data. So the link is the similarity is the same similarities.
It means that you are using the open linked data relation to make the relation in the text or something?
No, we are trying to structure and to annotate data, and the result will be connected to
the open
yeah.
linked data.
Yeah.
Ah, I see.
Via the
Okay.
UID, universal descriptor identifier,
Okay.
to give more visibility to the output of those tools.
More questions?
Okay.
Okay, so thank you very much.
You are the chair.
And the next presentation,
elle est malade, donc.
it's finished.
Ouais.
Okay.
I know it's nearly the time.
Ouais, on est dans l'enregistrement.